Okay, good morning to all of you. As I told in our last class that in this class we are going to discuss some numericals based upon multinomial distribution. Okay, and may you remember in our last two classes we have been discussed in detail about multinomial distribution, and how it will be the generalization of binomial distribution, that also we have been discussed. And in case of multinomial distribution, the general PMF, probability mass function, is this one: n factorial by x1 factorial into x2 factorial up to xk factorial into p1 to the power x1, p2 to the power x2 up to pk to the power xk. In detail we have been discussed. In our last class we discussed in detail about your moments and moment generating function of multinomial distribution. In our last class we have been discussed that what is the moments of bivariate distribution for two dimensional random variable, and we discussed um, about multivariate moment generating function. uh, in detail we have been discussed. Okay, and uh, in our previous class, uh, at the time of discussing the multivariate PMF, we have been discussed this problem: red, blue, green ball. We have to draw the five balls, and what will the probability that two occurrence of two red, two blue, and one green. Here, in case of multinomial distribution, the replacement has to be considered. That means you have to draw one ball and you have to again replace it. Okay, and also we discussed two numericals at that time. Whenever we are discussing the PMF of multinomial distribution, rolling of two dice or one die two times, and rolling of a die four times, and what will the probability that getting one, one time, two time two, one time five. These things we have been already discussed. So in this class we are going to discuss few numericals based upon your multinomial distribution. So I suggest to all of you that whatever we have been discussed in our last two classes regarding multinomial distribution, I suggest to all of you that you write down the notes perfectly, that it will help you at the time of your exam. Okay, so here in this class we are going to discuss seven numericals based on multinomial distribution. So before that, here I written that PMF, general joint PMF, joint joint PMF of multinomial distribution is your probability mass function, that is your p of x1 x2 x3 up to xk equal to n factorial by x1 factorial x2 factorial up to xk factorial p1 to the power x1 into p2 to the power x2 up to pk to the power xk. Here 3 points we have to remember: that x1 plus x2 up to xk equal to n, which is represents the total number of trials or observations, and p1, all the probabilities, if we are going to add, it has to be give you one value, and the replacement has to be considered. Okay, if replacement is not going to be considered, then that will be called as your hypergeometry distribution, but here replacement has to be considered. Okay, so first question is that if a fair die is tossed four times, this question already we have been discussed. Okay, here in our last class, but here I again written in systematically that you have to write down in your note itself. If you written, no problem. If you not written, here you have to write systematically. If a fair dice tossed four times, find the probability of getting one time one, two time two, and one time five. Okay, so how we are going to do this? Here n is your 4. That means four times observation or trials has been done. x1, which is belongs to number of ones happen. x1 is your 1. Number of 2's we got, that is your x2 equal to 2. See, x2 x1 is represent the random variable of getting 1. This one is represents the random variable of getting 2. Okay, and x3, in the question x3 is not there, so x3 will be 0. x4 we found in the question that x4 or the 4 will be come out at the time of tossing the die. So x4 will be 0, x5 1 time 5, so x5 will be 1 and x6 will be 0. Probability of getting each phase in a single trial. So this is your die. So if I'll be roll it or toss it, so chances of getting either 1 or getting 2 or 3, it will be 1 by 6. So probability of getting 1, 1 by 6, probability of 2 also 1 by 6, probability of 3, 4, 5, 6 also 1 by 6. So getting each phase in a single trial is for getting 1. For getting 1, that is your p1 will be 1 by 6, p2 also 1 by 6, p3 1 by 6, p4 1 by 6, p4 5 1 by 6, p6 also 1 by 6. Now applying MD, that is your multinomial distribution, in short I have been written, we get, that is the probability of 1. Here x1 is your 1. See how the joint PMF has been written, x1 x2 x3 up to xk. So in that way we have to write probability of 1 2 0. This is x1 x2, x3 is how much? X3 is your, in the question is 0 0, x4 is 0, x5 is 1. So mistakenly I written 7 numbers, 1 2 3 4 5 6. So this one is your 1 and this is your 0. This is nothing. So here x1 is your 1, x2 is your 2, x3 is your 0, x4 0, x5 1, x6 is your 0, right? So if we have to apply MD, that is your number of observations or trials, that factorial 4 factorial by, you can see, x1 factorial into x2 factorial up to xk factorial we have to consider. So 1 factorial, this is your x1, 1 factorial, this is your x2, 2 factorial, 0 factorial, 0 factorial, 1 factorial, and 0 factorial. Then here p1 to the power x1, p2 to the power x2 up to pk to the power xk. So p1 is 1 by 6 to the power 1, p2 also 1 by 6 to the power x2, x2 is your 2, x2, p3 is 1 by 6 but x3 is 0, p4 1 by 6 to the power 0, p5 1 by 6 and x5 is 1, so 1, p6 1 by 6 1 by 6, x6 is your 0 0 to the power 0. So finally we got that 4 factorial by 1 factorial into 2 factorial into 1 factorial, because 0 factorial 0 factorial 0 factorial are 1, 0 factorial is your 1. So here 1 by 6 to the power 0 is 1, 1 by 6 to the power 0 1, 1 by 6 to the power 0 1. So here 1 by 6 to the power 1, 1 by 6 to the power 2, 1 by 6 to the power 1 is nothing but 1 by 6 to the power 4, and the answer will be 12 by 6 to the power 4. Okay. Now we have to go for the second question, that is, if a fair dice similar question, okay, if a fair dice is tossed 12 times, in our previous question tossed 4 times, here 12 times, find the probability getting 1 2 3 4 5 and 6 points exactly twice. 1 we are going to get 2 times, 2 point we are going to get 2 times, 3 also 2, 4 5 6 points we are going to get 2 times. Okay, so here how many number of observations or trials? Here 12, so n equal to 12. x1 we want that 1 will be come up 2 times, so x1 equal to 2, 2 also will be come up 2 times, x2 equal to 2, x3 also 2, because we want 3 will be come up 2 times. X3 equal to 2, x4 2, x5 2, x6 also 2. And as I told that whenever we are going to be roll a dice coming of one point, that may be 1 2 3, the probability, each probability is 1 by 6. So now the PMF will be P of 2 2 2 2 2 2 x1 x2 x3 x4 x5 x6 will be equal to 12 factorial, that is your n factorial 12 factorial whole divided by x1 factorial x2 factorial x3 x4 x5 x6, all are 2, so 2 factorial 2 factorial 2 factorial 2 factorial into 2 factorial into 2 factorial, and this one is your p1 to the power x1, p1 is your 1 by 6 to the power 2, 1 by 6 is your x2, sorry, probability of 2, and x2 is your 2, so p2 to the power x2 also 1 by 6 to the power 2. Likewise this one is your belongs to p3 to the power x3, 1 by 6 to the power 2, 1 by 6 to the power 2, 1 by 6 to the power 2, and 1 by 6 to the power 2. This is belongs to our x6 is your 2 and p6 is your 1 by 6. So if you are going to solve it, you are going to get 0.0034. Okay. Now next question, a bag contains 5 red, 4 blue and 6 green balls. This one, a bag contain 5 red balls, 4 blue balls, 6 green balls. Okay, find the probability when 5 balls are selected with replacement and getting 2 red, 2 blue and 1 green balls. So we have to find out the probability that we have to draw the 5 balls from this bag with replacement. That means one ball I have been drawn, again I have been replaced inside the bag, again second one I drawn, again I consider to replacement, likewise. So here how many balls are drawn or how many observations, that is your 5, so n will be equal to 5. And here the random variables are red, blue and green. So red is represented as x1, so x1 how many we need, x1 we need your 2, x2 2, x3 1, so x1 will be 2, x2 will be 2 and x3 is your 1. By MD, by applying MD multinomial distribution, probability of 2 2 1 2 2 1 will be nothing but n factorial, that is your 5 factorial, by 2 factorial into 2 factorial into 1 factorial. Your numerator will be p1 to the power 2, because 2 is here, p2 to the power 2, p3 to the power 1. So here we have to find out p1 p2 p3. Here you can see that in a bag 5 red balls are there, but total number of balls are how many, 5 in plus 4 9 plus 6 15 balls. So if I am going to be draw one ball and it is belongs to red, what will the probability? The total number of red balls are 5 and total number of balls in the bag is 15. The probability of getting red will be nothing but P1 will be equal to 5 by 15, 5 by 15. Likewise, probability of getting P2, that means blue, will be 4 by 15. Here 4 blue balls, so 4 by 15. So probability of getting drawing one ball and it has to be green. What will the probability? Probability will be 6 by total number 15, 6 by 15. So P1 5 by 15, P2 4 by 15, P3 6 by 15. Now P221, P221 will be 5 factorial by 2 factorial into 2 factorial into 1 factorial. P1 5 by 15 to the power 2, P2 4 by 15 to the power 2, P3 6 by 15 to the power 1. So if you are going to solve, you are going to get 0.0948 is the probability of this question. Okay. A similar question here I have been written that you have to do by yourself. Same similar question. What is the question? This one, third number question, fourth number question is very similar. That the bag contains 5 red, 4 white, 3 blue marbles. Calculate the probability that 6 trials with replacement. Okay, in bracket this one it is written that with replacement you choose. So 6 trials you choose and you are going to get 3 marbles is 3 marbles are red, 1 marble is white, and 2 marbles are blue. So what will the probability? Here I directly written the answer, that is your 0.0899. You just do by yourself and match with this answer. Okay, and comment me in the comment section that are you got the correct answer or not. Okay, same, that is your 5. Here n is equal to 6, and x1 equal to 5, and sorry, x1 equal to 3, and x2 will be 1, and x3 is 2, and probability of p1 is nothing but 5 3 sorry 5 by 5 plus 4, 9 plus 3, 12. So p1 is 5 by 12, p2 and p3 you are going to calculate like this. Okay, so we have to go for the next question, question number 5. The question number 5 is, you are randomly selected cards from a deck. So here in a deck or a packet of cards, we know that total number of cards are 52. Okay, 52 total numbers of card in a deck. Every time you pick one, then you replaced. See, after watching this video, you write down the question perfectly and also answer. It will be helpful for your exam. Okay, perfectly you have to write down the note, which is most important. Then you replaced it back in the deck. Do this 5 times. So here we done number of observations are 5, or number of trials you can say 5, that is your small n is your 5. What is the probability of drawing one heart, one spade, one club and 2 diamonds? So we know that among 52, 13 cards belongs to your heart, 13 cards are belong to spade, 13 cards are belong to club, 13 cards are belong to diamond, that we know. Okay, so now we have to apply the multinomial distribution and we are going to solve it. So here, as I told, number of observations is your n equal to 5, and we want to find out the probability that drawing the 5 cards, the heart will be 1. So let this is one random variable, this is another, this is another, this is fourth one. So x1 is your 1, x2 has to be 1, x3 is your 1, x4 is 2. Okay, so you just apply the multinomial distribution, that is the probability of x1, x2, x3, x4 will be equal to n factorial. Here n is 5 factorial by x1 is your 1 factorial, x2 1 factorial, x3 1 factorial, x4 2 factorial into p1 to the power 1, x1 is your 1, p2 to the power 1, that is your x2 1, p3 to the power x3 is your 1, p4 to the power 2, because x4 is 2. So now we are going to find out p1, p2, p3, p4. We know that if I will draw one card that is belongs to heart, what will the probability? Because number of hearts in a packet is 13. So if I will draw a card and that is be belongs to heart, it will be 13 by 15, 52. 13 by 52. So p1 is 13 by 52. Likewise, I drawn a card and it has to belongs to spade, that will be also 13 by 52, 1 by 4. This is p3 that is belongs to suppose club. So 13 clubs are there. If I draw a card from the packet and it has to be one club, it will be, the probability will be 13 by 52, 1 by 4. Likewise for diamond itself, 13 by 52 is your 1 by 4, right? Now p x1, x2, x3, x4 will be equal to 5 factorial by 1 factorial, 1 factorial, 1 factorial, 2 factorial, and p1 means 1 by 4 to the power 1, 1 by 4 to the power 1, 1 by 4 to the power 1, and p4 is your 1 by 4 to the power 2. So you just solve it and you are going to get the answer 0.0585 is your answer. Okay, now we have to go for the. Now come to the next question, that is your here number 6. A large pool. Pool means collection of a sample of large number of persons of insured drivers are classified into three risk groups. Low risk is your 60% of all drivers. So here in this pool, suppose we have 100 persons. Suppose that this in this pool maybe 100, maybe 1000, maybe anything. Suppose we are consider 100. So low risk driver 60% means 60 persons or 60 drivers belongs to low risk. 25% of all drivers is belongs to medium risk, that means 25 persons if 100 number is your total, and 15% will be high risk, because high risk is belongs to 15%. So if 100 number of persons in the pool, then 60 number is belongs to low, 20 number will be medium, and 15 number will be high risk drivers. here here I given the example that may 100 persons in the pool, but this number can be anything. Okay, that may be 1000, that may be 2000, whatever may be. So suppose that n equal to 10 drivers, you are going to select randomly with replacement. With replacement means you have to use the MD, multinomial distribution, from this pool. Okay, uh, so from this pool we have to select randomly 10 drivers. Find the joint PMF of X and Y, where X, capital X, is represents the random variable which is belongs to low risk among the 10 drivers. Whatever we have been selected the 10 drivers from this pool, the X represents low risk drivers, Y represents the random variable of medium risk. So suppose for this case is your X, small x is your belongs to number of drivers among these 10, and small y is your number of drivers among these 10 drivers whatever you have been selected randomly from this pool. Okay, so this is your X is the number of drivers among the 10, this is your Y is the number of drivers among the 10. Medium risk, X is belongs to low risk, Y is belongs to medium risk. And here high risk driver random variable, it has been not given. But if we know X and Y belongs to low and medium and total number is 10, so obviously 10 minus X minus Y will be the rest drivers which is belongs to high risk. Okay, so we have to apply the PMF PMF with the help of our multinomial distribution. So probability of X, which is the number of low risk drivers among these 10 drivers, small y is the number of medium risk drivers among the 10 drivers. Obviously total number we consider 10, so n minus x plus y, so x is the low, y belongs to medium, so rest drivers if we are going to consider, that will be n minus x plus y, which is belongs to your high risk drivers, will be equal to n factorial by x factorial and y factorial into n minus x minus y factorial, because n minus x plus y will be nothing but n minus x minus y factorial, and p1 to the power x, p2 to the power y, p3 to the power n minus x. P1 is represents your low risk, p2 is represents medium risk, p3 is represents high risk. Okay, so p1 probability of low risk among the whole pool is nothing but 60 percentage, so p1 will be 0.6. so you can see that here n factorial, we have to put 10 factorial by x factorial y factorial into n minus x minus y factorial. Here p1 is nothing but your 60 percentage, so it will be 0.6 to the power x, and medium risk is your 25 percentage, so p2 is belongs to medium risk, so p2 we have to put 0.25 to the power y, and P3 is belongs to high risk. High risk percentage is your 15%, so obviously probability of P3 belongs to high risk will be 0.15 to the power 10 minus x minus y. This is your required answer, whatever asked in the question. Okay, so we have to go for the last question, question number 7. Here this is the question. I suggest you write down the questions and answer perfectly. Okay, the distribution of blood groups of a state as this one. That means type O blood group, AB blood groups, and the probability of blood group O is your 0.44, A 0.42, B 0.1, AB 0.04. You have to just add all the probability, you can get 1. Okay, here it is distribution, probability distribution mm, of a state having different blood groups. Okay, so in a state, large number of peoples are there, so among the peoples, statistically it has been found that probability of getting uh, blood group O is your 0.44, A 0.42, B 0.1, AB 0.04. Now consider 10 people are selected. Consider 10 people are selected randomly with replacement. Then find the probability of 6 half. So here 10 people means your this is your n. So 6 have blood group O, 2 have type 1, 1 has type B, and 1 has type AB. So here n is equal to 10, and x1 is your 6, x2 is your type this one, x1 is your 6, x2 is your 2, and x3 is your 1, x4 is your also 1. So now we have to apply MD, multinomial distribution. Then what we are going to get? The probability of 6, that means x1, x2, x3, x4, 6, 2, 1, 1 will be equal to total number whatever we have been considered randomly, 10 factorial by 6 factorial, 2 factorial into 1 factorial into 1 factorial. You just see that 6 plus 2 plus 1 is your 10 into P1 to the power x1. P1 is your 0.44 to the power 6. P2 is your 0.42 to the power 2. 0.1. P3 is your 0. This is 1 0. So here I written 0.1 to the power 1. And P4 is your 0.4 and x4 is your 1. So you just calculate it and you are going to get the answer is 0.0012. Okay, so here we have been discussed 7 numericals. You can try other questions by yourself by considering different books. So thank you so much for watching this video. I suggest again that you have to write the notes systematically and you have to write down these 7 questions in your note and complete it, and ready for the next class. We are going to discuss special continuous probability distributions. Here we have been completed the discrete probability distributions, discrete probability distributions that are your the so-called these are discretes: binomial, Poisson, geometry, negative, hypergeometric, and this is your multinomial distributions we have been discussed in detail. And next we have to start to discuss special continuous probability distributions. And continuous, in your continuous probability distribution, as per your syllabus, we have normal, uniform, gamma, exponential, chi-square, beta distributions. So we have to start to normal distribution. Okay, so thank you so much for watching this video. Thank you.